Have you ever looked at a weather map, really looked and seen all those weird little symbols and just kind of pretended you knew what was going on? Yeah, me too. Well, today, that ends. We are going to crack that code. We're going to learn the secret language that meteorologists use, and it's been hiding in plain sight this whole time. Okay, so let's look at a real weather map. See this thing right here over Kansas City? At first glance, it's just a jumble of lines and numbers, right? But what if I told you that little cluster isn't random at all? It's actually telling a whole story. I'm talking temperature, wind, how cloudy it is, you name it. So the big question is, what does this one tiny symbol actually mean? To figure this out, you've got to think of this map less like a forecast and more like a treasure map. Seriously, it is packed with all these little clues about what the atmosphere is doing. But the treasure, getting that full weather picture, is only unlocked if you can speak the map's language. So let's start with the people who make these maps. And the folks who are fluent in this language, well, we call them meteorologists. These are the scientists who do way more than just tell you if you need an umbrella. They're trying to predict the weather. And these coded maps, they're one of their absolute most powerful tools for basically seeing into the future. And here's the really cool part. The key is that it's all standardized. This isn't just some clever shorthand one person made up. Nope, it's a universal language. That means a forecaster sitting in Tokyo can look at a map of Topeka, Kansas and know exactly what's happening, instantly. It creates this amazing global real-time picture of our entire atmosphere. Okay, so how do we learn to speak this language? Well, like any good code, it's got a key. And the key we're about to look at, it unlocks the whole shebang. And here it is. This is basically our secret decoder ring, our Rosetta Stone for weather maps. Now, I know it looks like a lot at first glance, maybe a little intimidating, but trust me, this one sheet has every single symbol we're going to need. So let's just break it down. So that little symbol we've been talking about, the one we're trying to decode, it has an official name. It's called a station model, and it is an incredibly dense little diagram. It packs a ton of different weather measurements for just one location into one tiny little spot on the map. All right, it's time to put on our lab coats and perform a little surgery. We're going to dissect this station model and really look at the anatomy of the symbol, piece by piece. Okay, so this is our blueprint. See how everything is arranged? Every single number, every line, it has a very precise position and a very specific meaning. You've got temperature, pressure, wind, all this information just kind of orbiting that central circle. Let's start with the easy stuff first. Let's kick things off with two of the most straightforward pieces. See that number in the top left position? That's your temperature, in Fahrenheit. Simple as that. And the circle smack dab in the middle? That's not just there for looks. It actually tells us all about the cloud cover. And the way they show the cloud cover is it's a brilliant visual shortcut. If the circle is totally empty, you've got clear skies. If it's all filled in, it's completely overcast. And every level of shading in between tells you exactly how many eighths of the sky is covered by clouds. It's a whole weather report in just one little circle. So clever. All right, next up is wind. This whole line thing is called a wind barb. And listen up, because this part is super important. You have to think of it like an arrow, but an arrow that was shot by the wind. The line points back to the direction the wind is coming from. So if the line is pointing to the southeast, it means a southeasterly wind. Make sense? Now see those little feathers on the tail end? That's where we get the wind speed. And figuring out the speed is just some simple addition, which is great. Each long feather is 10 knots. A short little half feather is 5 knots. So all you do is add them together. So in this example here, you see 2 full feathers and 1 half feather. That's 10 plus 5 for a grand total of 25 knots. See? Easy. And finally, what's the weather doing right this second? Well, for that, you look at the symbol just to the left of that main circle. It tells you the present weather. A little comma means drizzle. A dot is rain. An asterisk is snow. And believe me, there are symbols for pretty much everything, from freezing rain all the way to a full-blown thunderstorm. Okay, so we've learned the alphabet of weather maps. Now it's time to actually read a few words. Let's put these new skills to the test and decode a real map for ourselves. So here's our mission, should you choose to accept it. We're going to go back to that weather map we saw at the beginning, and we're going to fill in the conditions for Kansas City, Fargo, and Cheyenne. Let's see if we can translate these symbols into plain English. Let's walk through one together. Let's look at Fargo. Okay, top left number. That's minus 15 degrees. Oof, cold. The circle in the middle is totally filled in, so that means it's overcast. The wind barb, it's pointing from the east, and it's got one full feather and one half feather, so 15 knots. And that symbol on the left, the two asterisks, that tells us it's snowing moderately. And just like that, boom, we have a complete weather report. And there we have it. The whole table is filled in. Look at that. Kansas City is at 29 degrees with some freezing rain. Meanwhile, over in Cheyenne, it's a balmy 63 degrees, but they've got a 25-knot wind coming in from the southeast. We literally just translated these super cryptic symbols into an easy-to-read weather report. It's a perfect example of just how powerful this station model system really is. I mean, just stop and think about what we just did. For every single one of those cities, we pulled out, let's see, temperature, cloud cover, wind direction, wind speed, and what kind of precipitation is falling. That's 5 key pieces of weather data from one tiny symbol. The amount of information packed in there, the data density, is just, well, it's incredible. And being able to pack all that information in so tightly isn't just some cool party trick. No way. It's the very reason this system, this language, is so absolutely fundamental to how we do modern weather forecasting. Think about it, because every meteorologist in the world speaks this same language. A forecaster in Tokyo can pull up a map from Chicago and understand it instantly. It makes it possible to share just enormous amounts of data in real time. And that's what allows them to track these huge weather systems, like hurricanes or big winter storms, as they move across entire continents. The source material we're working from puts it perfectly. It says a weather map is a quick snapshot of conditions at a particular time over a large area. I love that. And if the whole map is a snapshot, then the station model, that's the pixel. It's what makes the picture so sharp and full of detail. So let's just recap what you can do now. You can look at one of those crazy symbols and actually pull out the temperature. You can read the cloud cover just by looking at the circle. You can figure out not just the wind speed, but also its direction from that little barb. And you can recognize the basic symbols for rain and snow. You've basically learned the fundamentals of a whole new language today. So I'm going to leave you with a final thought to chew on. Now that you know how to read the basic building blocks of any weather map, what are you going to see next time you look at a forecast? What new details, what new stories, what new patterns are going to jump out at you? Pretty cool to think about, right?